to start us off, we are looking at our data table, okay? And what I want to make sure you guys have is you want to make sure you have all your data there. And then I kind of made a big deal yesterday telling you that these are your most important boxes on there, right? Those are what you're going to be using to do that ultimate calculating your average atomic mass. And I'm going to come around and I will check all the groups, okay, to make sure you're good. A reminder of your steps when you're doing that. You're going to take this percent and you're going to bump the decimal to the left, okay? Then you're going to multiply by the mass. That number you're going to put down here. And you're going to do that for the other two. So you're going to say bump, multiply by the mass, put the number down here. Bump, multiply mass, down here, okay? And then these numbers are the ones that you are going to add up in order to get your average atomic mass, okay? How many of us have already done that? And you are good to go. Okay, so that's what I figured. So those of you who are done with it, you guys are going to be working in your groups to make sure the other questions are answered. And people who are done with all of that, I would open your packet back up and start working on any little blanks that we have in there. Okay, you can start filling out tables, making sure you're going to be ready for your test on Monday. Okay? All right. Before I break you guys into your groups, everyone look at the front. Okay? Okay, so we have this nice little picture, okay? And what you were supposed to see on this picture was exactly what you guys had yesterday in hand. So you had a pile of candy yesterday, okay? And that pile of candy was supposed to represent 3 natural isotopes. The natural isotopes were Skittles, M&Ms, and Smarties, okay? This is not as fun. This one is magnesium 24, magnesium 25, magnesium 26. That's what you were supposed to get from it. But they are the same, it's the same idea, okay? So when you looked at this picture, okay, the first question is asking for you to write in the atomic number for each magnesium atom. You do not have to do that. What is magnesium's atomic number? It is not. So look it up. Huh? 12. It is 12. Thank you. Sorry if somebody had already said that. Okay. So we have 12 is our atomic number here. Okay. Does this magnesium ever change? Or is it always magnesium? It's always magnesium. So, does the atomic number ever change? No, they all have an atomic number of 12, okay? I need you guys to grasp that concept. Your atomic number isn't the thing changing. What is the thing changing on all these isotopes?
Amount of it.
No?
Okay.
Which number? Good. So it's your mass number, right? And your mass number is what? How do we get that number?
Protons.
You guys are great. Good. So we have protons plus neutrons give us our mass number. And that's what these things are showing us, okay? And what you're going to see is certain isotopes, certain flavors are going to have more. They're going to be more abundant than others, right? So yesterday in your lab, who was your most abundant isotope?
M&M.
Right, M&Ms, okay? And so that one is going to contribute to your average atomic mass more than the other two. So looking at, when you go to calculate your average atomic mass, you kind of want it to be close to the M&M because that one was the one that was most abundant for you, okay? That's the way to think of it. All right, but back on this picture, this says, what are the mass numbers of the naturally occurring isotopes? Can you guys answer that? For number 2. What are they? 24, 25, and 26. Good. Okay. Do they all have the same atomic mass?
No.
Why? How do you know that?
Because some of them have different numbers.
Okay, so the numbers are different, but what do those numbers show you again? What is changing to give you these 3 different numbers? The number of who?
Protons, neutrons, electrons.
Okay, so time out. Okay, so you guys told me earlier your mass number is your number of protons and neutrons. Those are your only 2 options here, right? Which one is staying the same the entire time? Thank you. Your protons are. Your atomic number right here is not changing. You told me they were all magnesium. That means they all have 12 protons. That's your guarantee. What is changing to give you different mass numbers? What is changing to give you different mass numbers? Protons are staying the same. What's the only other option?
Neutron.
All right, there we go. Okay, so they do not have the same atomic mass because they have different numbers of neutrons. So you can write that down. I'm not going to write it up here. Okay, so for number 3, because they have different numbers of neutrons, their masses are going to vary. That's how the mass number changes. I'll give you a second to write that down. So one more time, does the number of protons ever change? No, because your protons is the same as your
No, your mass number.
atomic number. Good, good. Your mass number changes because what changes?
Your neutron.
Neutrons.
Got that.
Awesome. Okay. All right. So number 4 on here said for the sample, draw a table including the mass numbers and 3 isotopes. What they want you to do is count them up. Okay? I don't know if it's all the words that are on this question, but this has been the biggest question all day. They're like, what do you want me to do? You just need to count them. Just like you had to count your Skittles yesterday and your M&Ms and your Smarties, you're going to count all the 24s, all the 26s, all the 25s, and just organize it into a little table. Okay? So this one is just about counting them. Number 5, I think you guys will be able to do. And number 6 is a challenge question. Attempt it with your group. Your hint on it is after you count, find out what that total was. And this question will be 10 times easier. Okay? You'll see with your group. All right. Okay. The last little bit, I'm not going to go over it too much. We'll go over this after I know everybody has done their average atomic mass. But make sure you can finish both of these tables. They are both required. Okay? So with your group, that would be the next thing that you can work on. So when I say go, you are going to get with your group members. You are going to make sure, because Ms. Vogel is going to come around and make sure that everyone has their average atomic mass. This is your top priority. Then you can start answering all the questions together. Okay? Do we all understand what our top priority is? Yeah. Okay, go. We see a reminder on how to write our isotope names. Okay? So if you notice, we are going to put the name, a little dash, that's that little line, and then your mass number. Is your mass number your atomic number?
No.
No. Okay, so mass number, remember, is coming from protons plus neutrons. Good. Okay, atomic number you get on the periodic table. All right, so the example that they gave you for this first line is calcium 40. That's how you would name the calcium isotope. Okay? All right. Then when you go to write your nuclear symbol, X is not a little element. It's a made-up little symbol. Okay? So we have X. We put mass number is always that top left number, protons plus neutrons. And your atomic number is always that bottom left number. Okay? So if we were to write this for calcium, calcium symbol is Ca. Okay? What goes on my bottom left corner? The bottom number.
The atomic.
Right. So I want to know what it is, though. Look at your periodic tables.
20.
What is it?
20.
20. All right. Did we see where we got that information? Okay.
Yep.
All right. And then we need to know what our mass number is. But we haven't even finished this yet. So let's look at the rest of our row so we know how to write our nuclear symbol. Mass number is protons plus neutrons. We can fill in atomic number. So let's go ahead and put a 20 right there. Okay. We know atomic number is always equal to protons. So let's fill in a 20 there. For this table, you are electrically neutral. So who is also equal?
Electrons.
Electrons, exactly. Okay. All right. I messed up about 2 seconds ago. We do have our mass number. Sorry. Where is our mass number located, you guys?
40.
It's the 40, exactly. Nice work. Okay? So 40. She's getting it from the name that they gave you. Okay? How do we calculate number of neutrons? Perfect. 40 minus 20 is equal to 20. Okay? You don't have to show your work if you don't want to. Just show your work if you need that reminder when you go to look at it later. Okay? So, one more time. Your isotope is about changing a mass number, and you change that mass number by adding or taking away neutrons, the things that don't affect the charge at all. Okay? You're just making a fat atom and a skinny atom. That's all it really comes down to, in my opinion. Okay? Are there any questions on isotope?
No, ma'am.
Right now. Okay? All right. So, let's look down at the bottom of the page. This is the part that I said, if you don't get it, it's okay. I just want the concept, okay? So, let's write down this first, and then we'll look at an example together, okay? So, your ion symbol is always going to have a little charge in the corner, okay? And you can kind of see on that chlorine example that they already have on your page, there's a little minus sign up in the top right corner. This ion symbol comes from your electrons being added to your atom or your electrons being taken away from your atom. And that happens when the bonding goes on, okay? And we'll see that, like I said, when we get to ionic bonding, you'll see how that's actually working, okay? But you do need to recognize what a charge is actually telling you. So as you can see, if I gain 2 electrons, if I gain 2 negativities, I have a -2 charge, meaning I'm -2 away from my electrically neutral. Okay? Biggest mistake is when I say gain electron, you think +2. No. Remember, they're negative. Okay? So for the test, I need you to have this concept down. That if you gain electrons, you become negative. If you lose electrons, you become positive. Exactly. Okay? Your ion symbol will still have the same little mass number, atomic number. The only new thing is you'll now have a charge number. Okay? And that comes from when you find out if it lost an electron or you added an electron. Okay? These examples, and then I will hand you your guys' test reviews, okay? So when you have your element name, okay, it's really boring. You always just say the name of the element and then you put ion after it. So this is a chlorine ion for that first row. Okay? Your ion symbol still looks like what we've been doing. So we still have our atomic number in the lower right corner. Okay, so on here you can see that it is 17. And I forgot what I was saying. Sorry. All right, so we have our atomic number in the lower left corner. And then above it, you have your mass number, right? So they gave you an 18 in your table. We use 18 and what? Which number? What is the 17 showing you? It's the what protons. Number? Well, it is the protons, but it's your atomic number, okay? So really get that into your head. Atomic number is protons, okay? So since they gave you the idea that it's chlorine, you looked on the periodic table, got 17. You now have atomic number, number of protons. We can add these two together to make our mass number, okay? The last tricky part is now what that minus sign means. So it had a -1 charge. So look at your little table that you just wrote off to the side. If you have a -1 charge, what happened to your number of electrons? No. You gained 1 electron. So look at this number. It is 1 more. See this right here? It's 1 more than your number of protons. Do you see that? So it's more negative. So if you're struggling with the table, don't freak out. Okay, I just need you guys to know this concept. If you are doing well, ooh. It's awkward. Okay, yeah. Be ready to answer how do isotopes and ions compare, okay? And that's what all the other classes did write down. So make sure you know that primary difference between the two. One has to do with neutrons changing, so masses change. The other one has to do with electrons